Exponential distribution is our topic of interest today, and we have the probability density function for the exponential distribution 1 over mu e raised power negative x over mu, and x should be greater than 0. We have an example to get us started. The length of time for one individual to be served at a cafeteria is a random variable having an exponential distribution with a mean of 4 minutes. What is the probability that a person is served in less than 3 minutes? So the first thing is we have been given the value of mu, and we have been told that the mean time is 4 minutes. And I could rewrite my PDF as 1 over 4 e raised power negative x over 4. What is the probability that a person will be served in less than 3 minutes? So I'm looking at x less than 3. And since exponential distribution is a continuous distribution, we are going to integrate from 0 to 3, 1 over 4 e raised power negative x over 4 dx. So that's the integral that we want to perform. And if we do that, this will give us 1 over 4. I'll take the 1 over 4 outside, and this will give me negative 4 e raised power negative x over 4. And then I substitute the limits of integration. So therefore, this will be 1 over 4, and that will give me a negative 1 over 4 times negative 4. So this one will be e raised power negative 3 over 4 minus e raised to power 0. And if I multiply it through with a negative sign, this will be equals to 1 minus e raised power negative 3 over 4. And that's the answer to our question. That is the probability, which is less than 1. Now, maybe I could go through the integral of e raised power negative x over 4 dx. When you are integrating, you take the power, you differentiate it, and if you differentiate negative x over 4, you get negative 1 over 4, so it will be e raised power negative x over 4 all over negative 1 over 4. And this gives me negative 4 e raised power negative x over 4. So that's how I arrived at this portion here. So the second question is, what is the probability that the person is served between 2 and 6 minutes? So that's the integral. I'll put 2 to 6, 1 over 4 e raised power negative x over 4 dx. And we have already done that. We found that it is negative e raised power negative x over 4, and the limits of integration is 2 to 6. So it is negative e raised power negative 3 over 2 minus e raised power negative a half. And so when I do away with the negative sign, it will be equals to e raised power negative 1 over 2 minus e raised power negative 3 over 2. And that is the probability that the person will serve between 2 and 6 minutes. So basically what we are saying is, if this is the starting point, so the person will wait for 4 minutes or more to be served. So this is the waiting time. So at this point they will wait. And there are a number of ways I can go about that. I can either get probability of x is greater than 4, alternatively I could say it is 1 minus probability of x is less than 4. So we can either take this or that. So if I use the first one, probability of x is greater than 4, I'll be doing an integral from 4 to infinity because it goes until infinity. We say that x is greater than 0, so it starts from 0 all the way to infinity. A quarter e raised power negative x over 4 dx. And since we are using the same equation, Since we are using the same equation, it will be equals to negative e raised to power negative x over 4, 4 to infinity, which will be equals to negative e raised to power negative infinity minus e raised to power 1. And what we know about this is we can write it as e raised to power 1 minus 1 over infinity. And the answer will be e raised to power negative 1, because 1 over e raised to power infinity will tend towards 0. It will be raising a number to a very big power, and then you divide with a very big number. So that will be the solution. So I could have done that way, or alternatively, I could have said it is 1 minus probability of x less than 4. So it will be, for me, I'll need to get probability of x is less than 4, which will be equals from 0 to 4, 1 over 4 e raised to power negative x over 4 dx. And then I subtract 1 from the solution. And this will be equals to minus e raised to power minus x over 4, 0 to 4, which will be equals to minus e raised to power minus 1 plus e raised to power 0. So it will be 1 minus e raised to power negative 1. So applying this, it will be 1 minus e raised to power minus 1, and that will be 1 minus 1 plus e raised to power minus 1, and that is e raised to power negative 1. And so the two are equivalent. So whichever step I took, I'll end up with the same solution.